so we are in our notes, and we are doing problem on the back of page 33. We are problem 6C. Hankins, what function are you using when you write your equation for 6C? Tan and why? We have opposite and adjacent, right? Very good. So tangent 52 equals opposite over adjacent. Multiply by 5. And we're ready to type it, right? So did you get 5 tangent 52? Oh, what did you get? I got 6.4.
Underneath the X, I didn't do it.
So the answer should be 6.4. Remember, Ferris, you're just doing regular arithmetic here, solving like you do any old equation. Alright, let's see. Hear from a female voice. Maya, what kind of equation would you set up for this one? Cosine 17. Remember, whatever function you use, the angle goes with that. So it's cosine 17, just like it was tan 52. The angle goes with the function, sine, cosine, or tangent. Adjacent over hypotenuse. Mr. Kaufman, how do we solve an equation like that?
Multiply by 10.
Multiply by 10, perfect. And we should have come up with 10 cosine 17, 9.6. Jordan, is that all right? You got an issue?
No, I'm trying to check. Oh, I did sign. I just did that number. I got 9.7.
Oh, well, we should be getting the same thing. Maybe I rounded wrong. I don't know. How did you get 9.7?
It's 9.6.
It's 9.56.
Oh yeah, my God.
And again, on a test or quiz, there'll be directions like round to the nearest tenth or round to the nearest hundredth. All right, here we go. Let's see. Caitlin.
Cosine.
And you are right. So cosine 63, remember, you always put the angle with, if you choose cosine, then it's cosine angle. And that equals opposite over, or excuse me, adjacent over hypotenuse, adjacent over hypotenuse. So Max, how do we solve that one?
You're going to divide 5 by cosine 63. Because you're going to have to multiply by x to get x.
Okay, there we go. We're going to multiply by x first. Yep.
And
then we're going to divide. So you were just ahead of me. You were confusing me there, but you're right.
I like thinking outside the box.
Oh, yeah. So now we're going to type in 5 divided by cosine 63, 11.0. You okay?
Yeah.
Everybody good? Yeah. Okay, now the moment we've been waiting for. Now we're actually going to do some real life problems. So all this junk that we've been learning up to this point is to help us to be able to do problems like on page 34, number 7. Page 34, number 7. All right, so here we go. A squirrel is sitting in the top of a tree. So I'm gonna draw my tree. Here's my tree. And we always assume trees are standing straight up, perpendicular. So we got a squirrel up here in the top of a tree that's 52 feet tall. Does that make sense to you? He is looking at a nut on the ground. So here's the squirrel, and he's looking down here. So here's the squirrel, and he's looking down here on the ground at a nut. See that right triangle I just built? His angle of depression is 23 degrees. I want every eyeball in the room focused right up here, because we're going to get this right. No one in this room is ever going to miss this. The 23 goes here. The 23 does not ever go here. Now you're saying, but Mrs. Ford, the squirrel is looking down at the nut. He is. His angle of depression is right here. If I am the squirrel looking down at the nut, the angle that my head tips through is my angle of depression. Well, that angle isn't even in the triangle. So we don't mark it there, we mark it here. From geometry, these are alternate interior angles. They're always going to match. If I am a squirrel looking at a nut, or if I am a worm in the nut looking at the squirrel, my angles are the same. So you are going to mark every angle of elevation or depression right there. That's where you're going to mark it every time. If you ever mark one here, I'm going to write some comment on your paper. Angles of elevation and depression always are marked right here. Whether I'm looking up or looking down, it's marked right here. Okay, what's the question? Find the distance from the nut to the base of the tree. So where do I put my X? Is this my X?
No.
No. What would that be? The distance from the nut to the squirrel?
Yeah.
Which is the top of the tree? I am looking for the distance from the nut to the base of the tree.
So your 23 degrees is your theta, right?
Yep, this is your angle right here.
Okay.
So you are going to do a problem like we just got done doing. You're going to set up an equation using sine, cosine, or tangent to figure out what x is. What function do you think we should use? Tangent. So we'll say tan 23. Remember, when you say tangent, you're always going to attach the angle to it. So it's tangent 23 equals opposite over adjacent. Okay, let's solve that step by step. First step, times by x. And final step,
Divide by tangent.
divide by tangent 23. So the answer to the question is 52 divided by tan 23. I got 122.5. Did you?
No.
I think I'm right.
I messed up.
And now this is a word problem, so we always attach a unit to that. What would that unit be? Feet. So the answer is 122.5 feet.
The squirrel seen a nut, 122. Seen a nut. He saw a nut 123 feet away.
Actually, the squirrel's even farther than that.
Yeah, it's even farther.
Yeah. It's a pretty amazing squirrel, isn't it?
Yeah.
Okay, and of course there was nothing in the way to see that. All right, gang.